Yeah. Now I hope my voice is clearly audible. Yes. So good morning, everyone. Yes, class is there. Class is there. So I hope you people are doing good. Now let's discuss. Yesterday we have been discussed about the consolidation chapter, means compressibility. See, now yesterday we discussed about what is compressibility and who is responsible for the compressibility. So the reasons for the compression and expulsion of water and expulsion of pore air and plastic readjustment of the solid particles. And the process of expulsion of air is known as a compaction, and the process of expulsion of water is known as a consolidation. So primarily, if I say consolidation, we deal about the primary consolidation. When I say consolidation, it's nothing but the primary consolidation. And in the case of the secondary consolidation can be seen mostly in highly expansive soils. So an initial consolidation, so it depends upon the amount of the air present in the soil mass. So this is the difference between the compaction and consolidation we have been explained yesterday. And then I took an example of a soil mass. So, and then I said you, first of all, due to self-weight, what is the total stress, what is the pore water pressure, and what is effective stress? And this is known as initial effective stress or initial overburden pressure. And then due to external load of such adjectives, these 3 points are very, very important. I'm telling you again, when an external pressure is applied on a fully saturated soil, initially entire pressure develops as excess pore water pressure. U bar is equals to Q. And later on, as the pore water dissipates, the excess pressure decreases. Then excess pressure decreases. And reduced excess pressure will develop as increase in the effective stress, which means in the case of the fully saturated soils, effective stress will not increase directly. Effective stress will increase when the excess pore water, means when the pore water dissipates, and then excess pressure decreases, and then only the effective stress is going to be increases. See, this table is very, very important. Please have a look over this table. So initially U bar is Q, external pressure, and as the process going on, excess pressure decreases and finally it becomes zero, and effective stress increases from 0 to Q. Whatever the reduction in the effective stress will be increase in the whatever the reduction in the excess pressure will be increase in the effective stress. And during consolidation, the properties of the soil that increases and decreases are, so this is a important point. So you see, some of the properties are going to be decreases. Some of the properties are going to be decreases, and some of the properties are going to be increases. You know that the major stress that is increasing over here is the effective stress. So I told you effective stress is responsible for the behavior of the soil mass. So I'm going to take the effective stress, and due to this consolidation or due to compressibility, let's take due to this entire compression process, as the volume decreases, void ratio decreases, and effective stress is going to be increases. So I will take a relation between the effective stress and the void ratio. So now you see here void ratio decrease and effective stress is going to be increase. So can you please tell me, does void ratio and effective stress are directly proportional or inversely proportional? Inversely proportional. During consolidation, effective stress increases, void ratio decreases. So now I'm going to make a relation between the void ratio, and effective stress to study the compressibility characteristics. To study the compressibility characteristics. So what is meant by this compressibility characteristics, sir? Number one, how much compression is going to be taking place? What is meant by compression over here? I told you. How much compression, which is nothing but what is this? Settlement, right? You observe over here, this is nothing but the settlement. So this is known as a settlement. How much a settlement is going to happen? Number two, the rate with which how the settlement is going to happen, means time required for the settlement. See, not only the settlement, we require the time required for the settlement also, and then we discussed about how this compressibility varies from soil to soil mass. So let's see all those factors into the consideration by taking the relation between void ratio and the effective stress. Yes. So now E versus sigma dash graph. E versus sigma dash graph. So let's see how to plot the graph. So here's x-axis. This is x-axis. In the case of x-axis, a sigma dash. In the case of y-axis, void ratio. So you know that at first, initially, you know, why you people? So please close the session earlier. Just now, our session has been started. Stop your things, and I am going to tell you what is the test, because all the people has not came in. That's the reason why I did not discuss the test details. So once they come, I will be discussing you. Okay, don't worry about that. I have already sent you a PDF yesterday, right? Now how to log in, that I will be telling you later. So first, please listen to the class, and while you are going through that, I will be telling you later. Okay, so don't worry, be patient. Everything has some time. Okay. So stop your questions about the examinations and listen now. I'll be telling you the examination details after this concept. So meanwhile, some of the people will be also joining. So don't worry about that. Now, you see, in the case of for any soil mass, you observe yesterday, I took this one or not? Yes. So I took this one before the application of load. I have a self weight of the soil mass. Yes or no? Due to self weight of the soil, definitely there must be some initial overburden pressure, which is nothing but sigma naught dash. So for every soil mass, due to its self weight, have a look. Due to its self weight, there is a one initial overburden pressure, and for that soil mass, due to means in the initial conditions, there must be some void ratio, let's take a E naught. Let's take it as E naught. So where you know that sigma naught dash means initial overburden pressure, which is nothing but due to self weight of the soil. Due to self weight of soil. And E naught as initial void ratio. See, this is before the application of the load. Mind it, this is before the application of the load. So now, you please remember all the 3 points. Now, I am going to apply a surcharge of Q. When I apply a surcharge of Q, at first, the entire pressure will be taken by the water and the change in effective stress is going to be 0. So this is the point number 1 I have been explained. You see, when an external pressure is applied on a fully saturated clay, so initially no change in effective stress. You can see this figure also. Yes, the change in delta sigma dash is going to be 0. What is mean by delta sigma dash? Change in effective stress due to external load. See, sir, why you take only surcharge? I can take any other soil mass. So just wait for that. I can be taking different also. Sir, in the effective stress concept, you said that total stress is directly proportional to pore water pressure. But now in this concept, you're saying that there is no effect for the total stress if the change in pore water pressure. Arey Baba, you don't know, means it's not about, don't say to me that, sir, you said that. It's you understood. You please go through the notes once again and then you come to me and then you ask the questions. I said differently and you understood it differently. So that's not my problem. So now at first the change in effective stress is going to be 0. And what happens during the consolidation? During the consolidation, as the pore water dissipates, effective stress is going to be more than 0. And during the consolidation, as effective stress increases, void ratio decreases. Yes or no? Now the question is, you know that initially more water used to dissipate. And later on, initially the soil is like this, initially more water dissipates, volume is going to be reduced by more. And later on, the amount of water decreases is going to be less. When the amount of water decreases is going to be less, the volume reduction would be less and the compressibility is going to be decreases or not. So I discussed these points yesterday only. So now you observe. You come over here. Now, see, due to the external load, the effective stress starts to increase. This is initial, and from here onwards, at this point, delta sigma z greater than 0. Delta sigma z greater than 0. When the delta sigma dash is going to be greater than 0, then the void ratio will be falling down or not. So now the volume will be fall somewhere over here. So now you see, let's take this one as a sigma 1 dash. Now it is going to be E1. And whatever from here to here, this is nothing but delta sigma dash. See the difference between this one. This is sigma naught dash due to self weight, and this is delta sigma dash due to whom? External pressure. As the pore water dissipate, how much reduced in the excess pressure will be increase in the effective stress, and the void ratio is going to be decreases from E0 from E1. And then later on, the void ratio is going to be, and then later on, the volume is going to, the effective stress is going to be increases further. When effective stress increases further, now initially more volume of water will be decreases. Yes or no? And later on, amount of water going out is less. When the amount of water going out is less, the reduction in volume is also going to be less. So now you see, this is going to be the void ratio. you see this is E1 and here it is going to be E2. If you observe carefully, from here to here, how much it has been decreased? More. And then later on, it is going to be decreases, which means that decrease in the void ratio will be decreases. The reduction in the void ratio will be decreases. So now, if you observe, so similarly, if I go for one more point, let's say finally, this is going to be the end of the consolidation. By the end of the consolidation, what happens is this is the change in the void ratio. So initially, this is void ratio, reduce it to this much, and then reduces, which means the compressibility of the soil mass is going to be decreases. Initial change in void ratio is more compared to final change in the void ratio. So now, if I join all these points, if I join all these points, so the graph would be like a curve. The graph would be like a curve. So now this is the initial void ratio. This is the initial void ratio, and at a initial overburden pressure sigma naught dash. And as the effective stress increases during the consolidation, the void ratio decreases. Finally, when it reaches to the end of the consolidation, what is meant by sigma f dash? Effective stress at the end of the consolidation. Effective stress at the end of the consolidation. So finally, now this is going to be the final void ratio. This is final void ratio. And we call this curve as Virgin compression curve. This is Virgin compressive curve. So now, whatever the slope this has is nothing but whatever the slope it is going to have, this is going to be AV, where AV is coefficient of compressibility. See, what is the meaning of coefficient of compressibility? The coefficient that represents the compressibility. You observe here, is it a curve or a straight line? This is a curve. And moreover that, this curve represents how the compressibility is going to be varies. It shows that over the period of time, the ability of a soil mass to reduce in the volume decreases, and finally it attains a constant value. You see, this is going to be almost constant or not? You see this graph? This is going to be almost constant, which means there is no change in the further void ratio. So now, how to find out this AV, sir? This AV is given as slope, change in Y by change in X. Change in Y by change in X. So what is change in Y? E naught minus EF by sigma F dash minus sigma naught dash. So where sigma F dash is final effective stress or effective stress at end of consolidation, and where sigma F dash is equals to sigma naught dash plus delta sigma dash. Sigma F dash means what is this? Initial plus change. You see, you observe that, this delta sigma dash is due to increase in effective stress due to whom? Due to external load. See, what is this initial overbottom pressure? Sigma naught dash. And what is this final overbottom pressure? Sigma naught dash plus delta sigma dash, where sigma naught dash is due to self weight and delta sigma dash is due to external load. Sir, but there is a mistake in this one. You please have 1 minute, I will be coming. But see, there is a problem with the slope. You observe here, whatever the slope I represented, do you think this is a slope of the curve? See, what is this? This is a curve, right? And this represents a slope of a straight line or not? Yes. You see, let me ask you one question now. If I take this point and this point as a final points, then this is the slope. And what about here? If I take somewhere over here, do you think the slope is going to be constant? Do you think the slope is going to be constant? No. As this compression curve is a curve, it is not a straight line. As it is not a straight line, then the slope is going to be changes. You know that for a curve, at this point one slope would be there, at this point one slope would be there, at this point one slope would be there. So in the case of the virgin compression curve, this AV is not going to be constant. This AV is not going to be constant. When AV is not constant, in order to study this one, what I do is now the same graph, everything is same with the same details. What I do is I have to convert this curve into a straight line. How come I convert a curve into a straight line, sir? Then the plot the same details in log plot, sir, or semi-log plot. So now E versus log sigma dash graph. This is the where is delta sigma? This is delta sigma dash nana. Whatever the sigma naught dash plus delta sigma dash is nothing but the sigma f dash. So now what I do is, let's take the same. Now, this is void ratio and this is a log or semi-log plot. I always tell you, in the case of graphs, log base 10. In the case of the expressions, means derivations, log base E. So now the same plot I am going to provide over here and here. So if that is the case, now the graph is going to be, this is a curve or not? Now if I plot into log scale, now the graph is going to be a straight line like this. So if you observe, at this point, See, let's say this is going to be initial overburden pressure, and whatever the void ratio is going to be E naught. Whatever the void ratio is going to be E naught. And let's say this is a final effective stress, and whatever the void ratio corresponding to this one, here this is going to be EF. See, this is also a compression curve, but in the case of the log axis. So now you tell me whatever this one here, the slope is not going to be same. But when I draw the same thing in terms of a straight line, wherever I take, the slope is going to be same. So let me take somewhere in between. See, you see, whatever the slope, now this is I am going to represent as a CC, where CC is known as compression index. CC is known as compression index. Sir, what is the CC value? Now you please tell me the CC value. So if this is the point and if this is the point, can you please tell me the CC value? And now let me take some point over here in between. So let's take this is some sigma dash and this is some E. And here also the slope is going to be same or not? Yes or no? Yes. So the slope is going to be same as it is a straight line. Wherever you take, the slope is going to be same. So now I can write this CC is equals to again delta E by, but this time log, right? Log A minus log B, log of A by B. Yes or no? Log A minus log B, log of A by B. So now I can write this one as a log base 10 sigma F dash by sigma naught dash. Sigma F dash by sigma naught dash. I can write this one as a E naught minus EF by log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. Yes. So now you see E naught minus EF. See, I am taking the magnitudes. I am taking just the magnitudes, not the signs. Please keep that in your mind. These are all the falling curves. The falling curve means the slope is going to be negative. So what is the slope over here is in simple words, I can write everything as, in simple words, I can write everything as CC is equals to delta E by log base N sigma naught dash plus delta sigma dash by sigma naught dash. Yes, I hope you understood over here. So what is delta E? Delta E is a change in the void ratio. Yes, you can take here and you can take here. So E naught minus E, if I write delta E, E naught minus E, then log base 10 sigma naught dash plus delta sigma dash, which means a sigma dash by sigma naught dash. I hope you understood the point. So now here this is going to be CC and here it is going to be AB. You just take the slope, that's it. You don't need to remember this one. These are the slopes. Okay. So if you know that one, now this is the CC value and this is AV value. Sir, which one I have to prefer, sir? We have to prefer CC, sir. For engineering calculations, always prefer CC because the slope is a straight line. The slope is whatever the slope is a straight line. So the straight line slope gives more characteristics than the curve. I hope you understood. So if you don't understood, then I would be removing the in-between portions. This is just for the sake of explanation. I told you, I don't want to keep much more ambiguity. You can take any point. You can take any point, and you know from here to here, the change in stress is going to be delta sigma dash. Yes. So can you explain the denominator? Yes. Denominator is nothing but what? Log A minus log B. Kya re? Log of A by B. Log of A by B. So log of A by B means what is A over here? Sigma F dash, which is nothing but sigma naught dash plus delta sigma dash by initial is going to be whom? Sigma naught dash. And now there is one more coefficient. That coefficient is coefficient of volumetric compressibility. Coefficient of volumetric compressibility represented with MV. See, this coefficient of volumetric compressibility means MV is equals to volumetric strain by volumetric stress. Volumetric strain by volumetric stress. See, what is meant by volumetric strain? What is meant by strain? You know the meaning of a strain. Change in length by initial length. But volumetric strain means a change in volume by initial volume due to volumetric stress means a increase in the effective stress. See, I am telling you again, mind it, you see, everybody have a look. What is the sigma naught dash? Due to self weight. Does self weight causes any compression in the soil? No. This entire change is happening as the delta sigma dash is going to be changes, then only these changes are going to be happen. Yes or no? What is delta sigma dash? Increase in effective stress due to external load. See, as the external load increases, then only means as the effective stress increases due to external load, then only the compression is going to be takes place. Please keep that in mind. Self weight does not cause any settlement or any compression. External load is responsible, and the stress due to external load is effective stress due to external load is delta sigma dash. So now, due to change in delta sigma dash, then the volume is going to be changes. So mv is equals to delta v by v into 1 by delta sigma dash. This is mv. Now let me show you. I hope you people remember this equation now. Everybody have a look over this one. This equation, please. I told you this equation yesterday by the explanation of all these things are. So now I am going to utilize this equation because whenever there is a change in volume, delta V by V is equals to delta E by 1 plus E. And I said you that total volume change is due to longitudinal deformation only. So now, I can write delta V by V as delta E by 1 plus E naught. From delta V by V is equals to delta E by 1 plus E naught. Now substitute mv is equals to delta E by 1 plus E naught into 1 by delta sigma dash. Yes or no? 1 by delta sigma dash. And what is meant by delta E by delta sigma dash? What is meant by delta E by delta sigma dash? AV. So mv is equals to AV by 1 plus E naught. So finally, the equation of this mv is going to be this one. So I have given you three coefficients. One is coefficient of compressibility, other one is compression index, and one more value is going to be coefficient of volumetric compressibility. See, there is an empirical relation for the CC empirical relation for CC. CC is equals to 0.009 into WL minus 10. 0.009 into WL minus 10. You know the meaning of WL. What is meant by WL? Liquid limit. This is for normally consolidated clays. Sir, what is this normally consolidated clay, sir? I will tell you later. NCC. NCC means normally consolidated clay. I will discuss the normally consolidated clay later. Means after this discussion, I am going to discuss that one only. NCC, but as of now, you please remember it as NCC. And similarly, CC is equals to 0.007 into WL minus 10. This is for the remolded clay. You know the meaning of remolding, process of disturbing. So if it is a disturbed clay, 0.007 into WL minus 10. WL minus 10, where WL is liquid limit. Sir, why you have discussed this one, sir? Sir, in chapter number 5, I discussed you. In chapter number 5, I discussed you more the liquid limit, more the compressibility. Liquid limit less than 35, compressible 35 to 50. Intermediate more than 50, high compressible, right? So which means compressibility of a soil depends upon the liquid limit. So compressibility representing whom here? Compression index. And this compression index depends upon whom? Liquid limit. So what is this NCC and all those things I will be discussing later. So now, note point. The note over here is, we have been discussed about three constants or three coefficients. So from all these things, what I want to give a note is, for engineering calculations, give preference for CC out of all coefficients, as slope is constant. As slope is constant. So as the slope is going to be constant, give preference to CC out of all the coefficients. Sir, why not MV? Sir, MV is also a function of whom, sir? AV, sir. And does AV has a constant slope? No. Because this is a curve. As the point changes, the slope is going to be changes. But you see the CC, the curve is going to be a straight line and slope is going to be constant. So for engineering practices, we don't go for the much complexities. We always go for the simplicity. The simplicity is, I will take the slope as constant, which means CC give preference. Give preference for the CC only. So now, yes. So now you see, sorry, what is NCC? Still I said, na, some people will be there. So what is NCC? Normally consolidated clay. Wait for that, I will be telling you later what is meant by NCC. So normally consolidated clay, NCC, normal C, consolidated C, clay. So now, why we are going to study all these graphs? See, we are going to study all these graphs. We are going to study all these graphs to know the compressibility characteristic. The first compressibility characteristic is settlement. How much settlement is going to be happen? Means maximum, you see, this is a building. This is a building. So as I told you, now see, if this is a ground level, you know that there is a self weight of the soil, but you know this is an external load, and you know that clearly in this zone, whatever, there is nothing but the self weight of the soil mass or not? Yes or no? And then not only that, due to this load, there must be some pressure passing through the soil, means passing through the footing. Now, due to this external pressure, then definitely the soil will undergo some compression or not? Yes. If it is a clay soil mass, and if there is a water table, let's take up to this level, then the water starts to dissipate. When the water starts to dissipate, then there is a settlement. So now I told you clearly, the settlement we are going to take only in the longitudinal direction, not any other direction. So this is known as settlement, where delta H is known as settlement. I discussed these things in the starting of the class. Now, why we are going to take care of all these things is to study this settlement. What is the maximum settlement? What is the meaning of maximum settlement? At the end of the consolidation only, right? At the end of the consolidation, because once the consolidation stops, what is meant by consolidation? Expulsion of pore water. If I say end of consolidation, no expulsion of water. When there is no expulsion, there is no change. So up to that point, the settlement will be increases or not? You know, during consolidation, settlement increases, and at the end of the consolidation, settlement will stop. So now, determination of ultimate or maximum or final settlement represented with the SF. So one by one. Number one, what is MV? MV is equals to, you know, that delta V by V into 1 by delta sigma dash. So now, from delta V by V is equals to delta H by H. From delta V by V, this is the determination of the ultimate or maximum settlement. So from delta V by V is equals to delta H by H. So now I can rewrite this equation as MV is equals to delta H by H into 1 by delta sigma dash. Yes or no? And what is delta H? MV into H into delta sigma dash. So now I can write, observe, see, for a given volume, delta H is equals to MV into H into delta sigma dash. Yes. So now for a given MV, if MV is going to be constant, you know that H is nothing but the thickness of the compressible clay layer. You know that H is nothing but the thickness of the compressible clay layer. See, whatever the clay is there, right? It must be having some thickness. Yes or no? See, whatever the thickness of the clay, let's take up to this point, it is going to be the clay layer, and you see this is the load from where the load is going to be transferred. So now the thickness of the clay layer which is under compression is going to be H. See, do not take the total thickness of the clay. Do not take the total thickness of the clay. The load where the load is going to be taking place, from that point, what is the thickness of the clay layer is known as H. And due to this load, the soil mass will undergo this settlement known as a delta H. I hope you understood. So what is this delta H? Settlement. MV, quotient of compressibility, which is constant. H, initial thickness of the compressible clay layer. Initial thickness of the compressible clay layer. And what is this delta sigma dash, sir? Now you tell me, sir. What is delta sigma dash, sir? So increase in the effective stress due to external load. Let's go back to our main topic. Please look over, sir. These 3 points, sir. Again, when time 0, what is delta sigma dash? 0. When delta sigma dash is going to be 0, when delta sigma dash is going to be 0, what is settlement? 0. What is settlement? 0. And as the time increases, pour water decreases, excess pressure decreases, effective stress increases. When delta sigma dash increases, settlement is going to be increases. See here, I can simply write delta H is directly proportional to delta sigma dash. So the more the effective stress, the more the settlement. At the end of the consolidation, yet end of consolidation, which means delta sigma dash is nothing but final minus initial, then delta H becomes SF is equals to MV into H into delta sigma dash. So this is the final equation. You please understand this one clearly. You please understand this one clearly. So now let me explain through this point. For example, initial time t is equals to 0, final and initial both are same. Final and initial both are same. So then delta sigma dash is going to be 0. When delta sigma dash 0, settlement is also going to be 0. What if this is 1? What if this is a 1? If this is sigma 1 dash, then this is going to be S1. If this is sigma 2 dash, then this is going to be S2. And this is sigma F dash, and this is going to be SF. So here, if it is sigma F dash, then S becomes SF. I hope you understood this equation. See, this is the primary equation, and from this, at the end of the consolidation, I told you the increase in the effective stress is nothing but final minus initial. Whatever the final effective stress minus initial effective stress. Similarly, now, as you know, MV is equals to AV by 1 plus E naught. This is one equation, and second one is, as you know, MV is equals to AV by 1 plus E naught. Can we write this SF equation as AV by 1 plus E naught into H into delta sigma dash? SF is equals to AV by 1 plus E naught into H into delta sigma dash. So you see here, this is MV and C. SF. How to determine the ultimate settlement based on the MV? How to determine the ultimate settlement based upon the AV? And what is the leftover here is going to be, this is going to be the CCR naught. Now, the third equation is The third equation is, you know that CC is equals to delta E by log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. Yes, but I want whom? Delta H. So now I will be using a from delta H by H is equals to delta E by 1 plus E naught. Can I write like this? From delta H by H is equals to delta E by 1 plus E naught. I can write like this because you know that earlier equations are delta V by V, and delta V by V is nothing but delta H by H. So from the relation, okay, I will be writing all this one. Delta V by V is equals to delta H by H is equals to delta E by 1 plus E naught. So now I can rewrite this form as, now you observe, delta H by H equals to 1 by 1 plus E naught into, what is this delta E? So now you see this delta E. Can I write this delta E as a CC into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. Sigma naught dash. I hope you understood this now. So now I can write this delta H. Yet end of consolidation, delta H is nothing but SF, because delta H means settlement, or SF means ultimate or maximum settlement. So now I can rewrite this form as SF is equals to CC by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. So now it's all about, you see, and again in this equation, also you observe here CC is a constant. Yes or no? Yes. And you know that initial, see, E naught is nothing but initial void ratio. What is this E naught? E naught is nothing but initial void ratio, and CC is going to be a constant. And you know that sigma naught dash is an initial effective stress. Initial effective stress. Array, in this entire equation, all are constants except this one. Yes or no? Except this one, everything is constant. Sigma naught dash means self weight. It does not cause any change. E naught, initial, no change. H, initial, no change. CC, constant, no change. The only change is delta sigma dash. Again, now you know, when time t equals to 0, delta sigma dash is going to be 0. So I can write time t is equals to 0, delta sigma dash is equals to 0, which means settlement is equals to 0. Yes, simple. If I write delta sigma dash 0, then what happens? What happens? Sigma naught dash by sigma naught dash 1, log 10, 0. Log 1 is going to be 0. So log 1 is going to be 0. And if time t is equals to t, then delta sigma dash is greater than 0, then S becomes greater than 0. If time t equals to infinity, then delta sigma dash is equals to external pressure and S becomes SF. So I want to show you that the settlement depends upon whom? Delta sigma dash. External load, pressure, then S becomes SF. I hope you understood these equations. So the most important equation out of all is this equation. I have been explained 3 coefficients. With all the 3 coefficients, I explained you how to find out the ultimate settlement. See, this is analysis. So now how to find out everything in reality? Let's see. I'll be discussing with reality. Don't worry about that. Model number 1. So now coming to the model number 1. In the case of the model number 1, let me take the same state of the soil mass I have been explained yesterday. So this is the ground level, and here it is going to be sand, here it is going to be clay, and here it is going to be sand. So this is the thing that I have been explained yesterday also. Now I'll show you that one. Please have a look. This is the same example that I have taken yesterday. So now I'm taking the same example, and now I'll be explaining. See, we have been discussed about the primary consolidation. We discussed about how to determine the ultimate settlement, right? Now I'm explaining the terms again in the same thing. If this is the condition I give to you by applying a surcharge Q, how the ultimate settlement is going to be find out. Now you see, let's take a surcharge. This is a surcharge of Q. This is a surcharge of intensity Q. So now I need to find out the ultimate settlement. How to find out the ultimate settlement? So what is the equation? Just now we discussed that equation. SF is equals to Cc by 1 plus E naught into H into log base 10 sigma naught dash, or SF is equals to Cc by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. See, you know that, see, if the water table is going to be located over here, first of all, Cc. That Cc, see, we are discussing about the consolidation or ultimate settlement in whom? Clayey soils or sandy soils? Clayey soils. So let's say the clay has a water content of W and a specific gravity G and liquid limit WL, and the soil is NCC. NCC means normally consolidated clay. So these are the properties of the clay soil mass. Then what I need to find out is first of all Cc. What is Cc? 0.009 into WL minus 10. See, already I have given you for the clay layer what is the WL, which is mean by liquid limit. So this is for the normally consolidated clays. This is for the normally consolidated clays. And now what is E naught? E naught means initial void ratio. Sir, how come I find out the initial void ratio, sir? Sir, now you see, sir, water table is going to be here, sir. As this is a water table, sir. Entire clay is under saturation, sir. Yeah, not visible now still. Yes. So now you see this equation SF is equals to, I need to find out the ultimate settlement over here for the clay layer. So find the ultimate settlement in the clay layer. So now you see SF is equals to CC by 1 plus E naught. Mind it, I am discussing the clay. I am telling you again and again. Clay. So what is CC? Compression index. CC means compression index. So I gave you for compression index the empirical formula is, if I say the soil is NCC, then it is going to be 0.009 into WL minus 10. This is going to be 0.009 into WL minus 10. See, I did not discuss anything much over here. I just drawn this figure. That's it. I just draw this figure. I have given you this figure earlier or not? Yes. So now E naught is going to be initial void ratio. How to find out that? To W into G, sir. So if I write E naught, if I write as E naught, let me check that. Yeah. If I write E naught, then SR is equals to 1. When SR is equals to 1, because the soil is fully saturated or not? Yes. Because there is a water table, then how to find out E naught? W into G. See, as the water table is going to be there, fully saturated, right? Then how to find out E naught? Yes, we got. Then H. H means initial height of compressible clay layer. Initial height of or initial thickness of a compressible clay layer. See, what is the meaning of compressible clay layer, sir? Compressible clay layer, see, this is a clay layer, and whatever the clay layer that is under compression is known as a compressible clay layer. Audio is not clear. Now still audio is not clear. Still, please let me know once again. Still audio is not clear. Now it's clear. Yes. Yes. See, I just explaining you the things. That's it. I'm not discussing any topic over here. So now I just discuss the things. That's it. This is the figure. This figure we have been explained yesterday. Yes. See, this is the figure, right? Yesterday I have taken for primary consolidation. I took the same figure, and now I am finding how to determine the ultimate settlement. So for that I have written the equation SF, where CC means compression index, how to find out that. And E naught means initial void ratio, how to find out this one. If they give W and G, as the soil is fully saturated, you can find it out as the soil is fully saturated, then E into SR is equals to W into G, you can find it out. Now the H. H means initial thickness of compressible clay layer. See, what is the difference between clay and a compressible clay, sir? Sir, compressible clay layer means the clay layer which is under compression, which means whatever the clay layer below the load is known as a initial thickness of the compressible clay layer, which means whatever this is. See, this entire clay, this entire clay is under compression or not? So that is going to be the H. So what is H? Thickness of the clay which is under compression. Now the end is going to be sigma naught dash and delta sigma dash. Sigma naught dash and delta sigma dash. So sigma naught dash plus delta sigma dash. I need to find out the stresses. Where we are going to find out the stress is, we are going to find out the stresses. Sigma naught dash and delta sigma dash are should be calculated at the mid height of compressible clay layer. At the mid height of compressible clay layer. Please understand this point. This sigma naught dash and delta sigma dash should be calculated at the mid height of the compressible clay layer. See, this is a clay, and this is going to be the mid height of the compressible clay layer or not? Yes. So now you know that at the mid height means this is going to be H by 2. Let's take this one as some Z. Let's take this one as Z. So at this point, what is the sigma naught dash and what is the delta sigma dash? Sir, why we are taking the mid height, sir? Average, sir. We are going to take an average. See, the clay has a top, has a bottom, has a mid. Now the question is where to find out the stress. In order to find out the stresses, you need to know the point where you need to find out, right? Are you going to find out at top, or are you going to find out at bottom, or you are going to be find out at the average? We have to take the average, not at top, neither at the top nor at bottom. We are going to find out the effective stresses. Sigma naught dash means due to self weight. This is due to self weight, and this is due to external load. So external load, stress due to self weight and stress due to external load should be calculated at the mid height of the compressible clay layer. So can you please tell me, you know that E into SR is equals to W into G. So if I write E naught, then we can get this. This is going to be E naught W into G. And at a mid height, of clay, or I can write that at mid height of the compressible clay layer. See, already I have written this one. Now, what is sigma naught dash? The sigma naught dash means due to self weight or not? Yes. So listen, whatever this is nothing but sand, gamma dash of sand into Z plus gamma dash of clay into H by 2. Yes or no? Because where I am finding at the mid height of the compressible clay layer at this point, what is effective stress due to self weight? Everything is under submergence or not? Gamma dash of sand into Z plus gamma dash of clay into H by 2. And what about this delta sigma dash, sir? Sir, at the end of the consolidation, sir, at the end of the consolidation, sir, delta sigma dash is nothing but Q, which is going to be surcharge. At end of consolidation. See, if this is the condition, if you want to find out the effective stress, if you want to find out the ultimate settlement in this clay layer under the effect of this surcharge Q, you see the equation, and in this equation I explained one by one Cc, E naught, H, and where to find out sigma naught dash and delta sigma dash. So what is sigma naught dash over here? Gamma dash into sand into Z, plus what is the sigma delta sigma dash? Gamma dash into clay into H, sorry, Q, which is going to be at the end of the consolidation. So sand is also under compression. Yes, sand is under compression, but it's not under the consolidation, right? We are discussing about whom? Consolidation. We are discussing about consolidation, not compression now. See, sand is also under compression, and sand has immediate settlement that is very less. If I say yes, F, that is the primary consolidation settlement I'm discussing. So when I say consolidation, I do deal with about only clays, not about the sand. And after all the discussion, some of the people are asking, sir, what is SF? Yes, for everything we can take mid only. Yes, we have to take in our mid only. Sir, but in most cases, we cannot end up in complete end of consolidation. So no, we cannot end it. That's the reason why. See, I'm not discussing about time, Nana. Whether the time is 100 years, 150 years, I don't care. I'm not discussing about time. I'm discussing about what is the magnitude of end settlement. Sir, why you don't subtract pore water pressure in initial effective stress? अरे भाई, आपको दिमाग है या not? आपको दिमाग है या not? ये क्या रे भाई, गामा डैश है ना भाई? What is mean by gamma dash? अरे where the hell are you people are coming, Ray? I'm not understanding. That is a direct substitution of the sigma naught dash, right? What is the effective stress? Okay, fine. If that is the case, then I have to go with the, okay. So my dear student who has asked this question, now let me represent this in this fashion. Sigma naught dash means total stress minus pore water pressure. So I hope total stress, what is total stress? Gamma sat of sand into Z plus gamma sat of clay. Okay, I will just show you yesterday's class. So the person who has asked me this question, you please go through this one. Yesterday I have discussed this one. You please go through this one. I will be writing over here itself now. You please tell me what is sigma naught dash? Sigma naught dash means gamma sat into Z plus what is HP here? Gamma W into H by 2 plus Z. If you rewrite, these are going to be gamma dash into sand Z, gamma dash of clay into H by 2. So this is going to be the equation. That's the same equation I have written over there. And sigma naught dash, gamma dash of sand into H by 2, sorry, into Z plus gamma dash of clay into H by 2. Sir, will they always ask settlement at the end of consolidation only or during the consolidation also? Wait. I will be discussing that, right? I am explaining now. What I'm explaining, you please tell me. I'm explaining the determination of ultimate settlement. Yes, I'll be telling you that. Sir, if we have two clay layers, we have to take average. No, if you have two clay layers, You have to find out the settlement in 2 clay layers and you have to add both, not average. Sir, if load is not surcharge, what is the change in effective stress? Wait for that. Now I am going to show you. Only for clay height, sir. Yes. What is NCC? See, this is the 4th time I said you. Wait for that. You mean it maximum boundary condition by considering the complete consolidation? No. The meaning of complete consolidation means entire excess pressure should dissipate. Means entire excess pore water pressure should dissipate. Sir, as we know, external load intensity decreases as the depth increases. Now, wait for that, my dear Bhargava. Now, next one. Sir, is SF is independent of time? Yes, my dear. SF means final settlement. Whether it is 50 years or 20 years or 100 years, it does not depends on time. It is independent of time. What is the meaning of final? Maximum. We never know when it is going to be happen. Sir, if we have 2 clay layers having different properties, we have to take the coincidence of 2 layers. No, if there are 2 clay layers for different properties, you need to find out the settlement in both the clay layers and you finally add those settlements. Sir, why in SF H is not substituted as a H by 2? You please remember this by what is meant by H? That is the initial thickness. The stresses are going to be found out at center, not the thickness, please. What about the self weight of the foundation? We neglect that. What if we didn't attempt the test? You don't need to attend my classes. If you don't attempt the test, you don't need to attend my classes also. Just you please take care, means you take rest in your home and eat, sleep well, and you become fat over the period of time. That's very, very good for you. Please don't attempt the test and don't attempt the class also. Sir, is SF is due to primary consolidation only? Yes. Sir, complete consolidation is the settlement maximum? Yes. Sir, if water table is at the clay layer, then you tell me, sir. You tell me what happens, then effective stress is going to be changes, right? If water table changes, effective stress is going to be changes. Okay. So now all of your doubts are going to be now removed with this next example. Example number 2. See again, this is a ground level. And this is the point load. Let's take B is the width of the foundation. This enter is a clay layer above and below. This enter is going to be the clay layer. So let's take the depth of the foundation as D, and water table is located at the ground level. Water table is located at the ground level. This is the water table located at the ground level. Now I need to find out the ultimate settlement. So assume 2 vertical to 1 horizontal load dispersion. Assume 2 vertical to 1 horizontal load dispersion. So now this is a model 2. I'm explaining you. This is a model 2. So come on, everybody, please tell me what is going to be happen over here. See, I want to find out SF. What is SF? I'll be writing the equation once again. I'll be writing, see, you write the equation n number of times. You write down the equation n number of times. Cc by 1 plus E naught into, let's take, this is the end of the clay layer. And there is some hard strata located over here. Cc by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. Or simple words I can write as a final stress. Final stress by initial stress. What is meant by final stress? Sigma naught dash initial stress plus delta sigma dash. So first of all, what is meant by Cc? Cc depends upon whom? Liquid limit. So generally we take soil as a normally consolidated clay. After this topic, I am going to discuss about the normally consolidated clay. So wait for that moment. And what is the void ratio? Initial void ratio. Let's take it as a E naught. Or I can find out if I know the water content and specific gravity. And now H, what is meant by H? I told you H is nothing but the initial thickness of the compressible clay layer. So everybody observe. See, this entire is a clay layer or not? This entire is a clay layer. But should I have to take the total clay layer or compressible clay layer? I have to take the compressible clay layer. See, this load is going to be transfer through the base of footing. The load is going to be transferred through the base of footing. Yes or no? Yes. The load is going to be transferred through the base of footing, which means the soil below the footing is under compression. So H is nothing but thickness of the clay layer, which is under compression. Which is under compression. In this zone, this entire clay is under the surcharge. But in this zone, the clay layer under compression is just below the base of our footing. So here, clay layer below base of footing is under compression. Is under compression. So now, please look over. So whatever, this is nothing but the thickness of the compressible clay layer. As you know, whatever the soil or whatever the clay which is under compression, that height is going to be thickness of the compressible clay layer. I hope you understood. I did not take the total clay because the clay layer below footing base only is under compression. So the thickness should be taken below the footing only, because H is the thickness of compressible clay layer. So now what is remaining, sir? Sigma F dash, sir. What is sigma F dash, sir? Sigma F dash means, because I am discussing about the SF, then yes, F final, because this is going to be final. If I ask S1, this is going to be sigma 1, S2, sigma 2, S3, sigma 3, and whatever this SF is sigma F dash, where sigma naught dash plus delta sigma dash. Where we are going to find out the sigma naught dash and delta sigma dash should be calculated at a total clay layer or compressible clay layer. Compressible clay layer. Now you tell me what is the total thickness of the clay? H plus D. So now my question is, should I calculate the stresses at H by 2 or H plus D by 2? H by 2 or H plus D by 2. I told you clearly stresses should be calculated at the mid height of compressible clay layer. Whatever this zone, this is known as compressible clay layer. So in this zone, the mid height is going to be exactly somewhere yes, this is the mid height. Mid height of the compressible clay layer. So what is this mid height now? This mid height is going to be h by 2. At this point, I need to find out sigma naught dash and delta sigma dash. So now, can you please tell me what is sigma naught dash here, everybody? The person who has asked me what is the question earlier, you please tell me, Nana. This is the water table. Below the water table, and everything is submerged. So I can write directly gamma dash of clay. So total is going to be clay layer only, right? Total is a clay layer only. So as it is a total clay layer, at this point, what is the stress? Gamma dash into D plus H by 2. This is a effective stress. But now, what about the delta sigma, sir? Sir, this delta sigma dash is due to stress due to external load only, right? Stress due to external load. See, I hope you remember the chapter number 10. Vertical stresses due to external load. This assumed two vertical to one horizontal distribution is nothing but approximate distribution or not. I hope you remember. See, if this is the load is not going to be changed. The load is not going to be changed. But when this load is going to be transferred beneath the footing, the load will disperse with a two vertical to one horizontal distribution. I hope you remember in the chapter number 10, there is a method known as approximation method. And if you remember that, then the load will disperse. The load will disperse with an angle of 2 vertical to 1 horizontal. And whatever this depth, this is going to be Z. And if this is Z, I hope you please remember, I hope you remember that whatever this total width is going to be B plus Z. So where Z is going to be how much here? Please tell me where Z is going to be how much? H by 2. So if you remember, then delta sigma dash is equals to Q by B plus Z whole square. If footing is going to be square. Square footing. Q by B plus Z into L plus Z. If it is going to be rectangle footing. And what is this Z value, sir? Z is nothing but below the base of footing up to the point, right? Here the Z is going to be H by 2. I hope you understood here. So you please look over. So I'll be explaining the points again, once again. First, the given is going to be Cc, and Cc depends upon liquid limit. E naught depends upon the void ratio of the soil, and H is nothing but thickness of the compressible clay layer. This is going to be H, and I need to find out the stresses. How we are going to find out the stresses is sigma naught dash plus delta sigma dash. So where sigma naught dash means due to self weight, which is nothing but gamma dash, whatever the soil mass, if it is going to be gamma sat, gamma dash of the clay into D plus at center H by 2, and I need to find out the stress due to external load. I hope you remember this equation from the 2 vertical to 1 horizontal distribution. See, here the external load is surcharge. Here the external load is going to be surcharge. And here the external load is going to be taken as by means of a 2 vertical to 1 horizontal distribution. Okay. So that's about this. So in calculation of total stress, we consider external load intensity same at every time. See, I did not take in the external load intensity. I took the surcharge. When I take surcharge, it is going to be same at every depth. But is it a surcharge? Is it a surcharge? Please tell me. Is this a surcharge? No. So see, I explained you in chapter number 10, there are a lot of theories. Bosnis theory, point load, Westergaard's point load, circular loaded area, Newmark's method, Newmark's chart. In the same question, I do one thing. If footing is a rectangle, of dimensions L by B and given details M, N and I. I hope you remember this one. Now you tell me, if the footing is going to be rectangle and given details are going to be M, N and I. See the rectangle whose dimensions are L by B. Then to determine delta sigma dash, use Newmark's method. So then I will be asking you exactly at center, what is the settlement at a depth of at the center of the compressible clay layer under the center of the footing. See, as a type of footing changes and the given details changes, you can go for the different methods. So to determine delta sigma dash, use Newmark's method. So you know the Newmark's method, right? What is the Newmark's method? Delta sigma dash is equals to I into Q. That's it. And what is this Q over here, sir? Q is going to be capital Q by area of footing. So this is, see, what I want to explain over here is for various loadings, the delta sigma dash is going to be changes. If it was a surcharge, so at the end of the consolidation, it was surcharge, delta sigma dash is equal to Q. And here this is due to 2 vertical to 1 horizontal distribution. And if I take the footing is rectangle and given details are like this, to determine delta sigma dash, use Newmark's method. So that's about this condition. Yes. So now let's solve some questions based upon this. Then you can understand these concepts much more better. Yes. Yeah, some of the people who are very interested in about the test, and now I shared this one yesterday. Yes. So the pattern of the examination again I am going to discuss you. Examination will be conducted on Tuesday, which means today. I hope everybody is there over here. Those who came, that's fine. Time 6:30 p.m. and duration is going to be 75 minutes. So I am going to give 20 questions, 10 marks. Means 10 questions as 1 mark, 10 questions as 2 marks. Total marks is 30, and negative marking will be only for MCQs. For 1 mark, negative is going to be 0.33. For 2 marks, negative is going to be 0.67, and there is no negative mark for the numerical type. And virtual calculator will be provided for you. Pattern of examination is similar to GATE and ESC level, which means I would be giving you the ESC prelims like questions statement wise, assertion reason, and GATE level wise as conceptual bits also. So this is the pattern. And now how to log in? Log in with your details provided at 6:30 p.m. and open course Geotech So just like how you are going to see our live classes, you see, while you are going to look over the live class every day, you are going to go for that your packages, and then you see the Geotech classes, right? So CE live classes there, course Geotech, and test would be there, and it will start at 6:30 p.m. only. It will start at, see, just exactly how you are going to log in with your details and how you are going to attend the class. Similarly, if you go for the same way, there is a one more option, and it will be pop up at the evening. So it will start at 6:30 exactly. So you please keep yourself with the internet and mobile data or whatever it is. It won't consume much of the mobile data because it's not in a video class over there. It's just a test. So it won't take much data. It will be consuming very less data only. So please make sure the time 75 minutes, and at the end of the time, it will be give you result also. So whatever the questions are, I have given the solutions also there. So after at the end of the test, it will be redirected and give you the result that you got. So, and whether it is negative or positive, and it will show you the mistakes that you have done also. Please go through that. This was about the examination details. Yes, you can give the test on the mobile also, not only on the computer. You can use it test also. See, you please keep your mobile data next to you, and if it is comfortable for you to do the in mobile, then you can do it. मार्क्स सर अरे अबे क्या रे भाई, आपको दिमाग है ना यार देखने के लिए? क्या रे भाई, आर यू ब्लाइंड और व्हाट? क्या रे? एंड अगेन यू आर आस्किंग टोटल मार्क्स. Okay, fine. Yes, the answer key will be shared. No, so please take less class today. No, I won't take any less class today. I won't be leaving you before 1 or 1:15. Result will be displayed at the end. Sir, who will do mass copy, then who will get the top? They will feel proud, sir. I told you, see, the persons who do the copy, they can fool. They think that they are fooling me or other students. But the point is, you are fooling yourself. Sir, you seem to be very angry today. No, Ray, I'm not angry. Actually, I don't get angry usually. In in normal offline classes, generally I don't get angry. But you see the questions, right? When I say the question, you people are all listening to those questions also. I hope so. So you see the questions are how some people are asking. I'm not saying about they are bad, but somehow you're missing. While I was repeating the same points, see, I don't do repeat these many times in the offline classes. In offline class, we do not discuss the topic again and again. Here I am discussing the topic and I'm clearing you the doubts in between also. and I'm giving you the video lectures, I'm giving you my own notes, my PDF, and I'm sending to you after all the efforts I am taking. If you are asking means silly doubts means which means that you are not giving importance to the subject. You don't need to respect me. See, I don't want any respect from all of you at the end of the day. Whether you give respect to me or not, I don't care about those also. But give respect to the subject. That's what I said. When you're asking some question, please remind yourself whether I am asking legitimate question or not. Because that's not going to be time waste for you. It's going to be time waste for all of us. Yes. Okay, result will come immediately. Now let's see the some of the problems. Like I want to see before giving a break, I want to solve those problems so that you can understand the concept much more better. Please stop and listen to now. Yes, everybody, have a look over here. First of all, let me go to the directly question number, yes, 11 and 12. You see the question number 11 and 12. See, I have given you this question. Please look over this question. A 5-meter depth of sand overlies a 6-meter rail of clay. A 5-meter sand is there, overlies on a layer of clay. So on the top 5-meter sand, below 6 meters clay is there. The water table is at the top of the sand. See, water table is at the top of the sand means water table is at ground level or not. The permeability of clay is very low. So they gave sand, they gave clay, and water table is at the sand. Permeability is very low. Saturated unit of the sand and the clay are 18 and 20. A 4-meter depth of fill of unit weight 19 is placed on the surface over an extensive area. What is the meaning of 4-meter fill surface over an extensive area? What is the meaning of over an extensive area? Surface area is more. So if an external load is applied over a larger surface area, I can take it as a surcharge. So, and what is the unit weight of the soil mass fill? 19. And how much depth? 4. Then what is the intensity of surcharge? 19 into 4. So 19 force, 76 kilopascals. Assume gamma W is equal to 10 kilonewton per meter cube. Now, what the question I am asking you here is, what is the question I am asking over here is, so the effective vertical stress at the center of the clay layer immediately after the fill has been placed. The effective vertical stress at the center of the clay layer. The effective vertical stress at the center of the clay layer. I am asking you at the clay layer immediately after the fill has been placed, assuming the takes place rapidly. See, what I am asking you is immediately after the fill has been placed. Another one is effective vertical stress at the center of the clay layer many years after the fill has been placed. Many years after the fill has been placed. So I am asking you, if you place fill immediately, what is effective stress? And what is the effective stress? Many years. Now, let's see this question. If you understand these 2 points, what is the meaning of immediately? When time t is equals to 0. What is the meaning of many years? When time t is equals to infinity. The only point that you need to know is, Are Baba, a water table hai na? When there is a water table, you know that when you apply external load, this is the point I told you n number of times. Now I am repeating again. When an external pressure is applied, who will be taking first? Water. And what is the change in effective stress initial? 0. What is the change in effective stress initial? 0. And as the entire pore water dissipates, excess pressure will dissipate and effective stress will be increases. So you see this point? You know this point, right? When external pressure is applied, fully saturated, initially, no change in the effective stress. Initially, no change in the effective stress. And at the end of the consolidation, the entire change in effective stress is going to be increase in the external, sorry, whatever the external pressure you applied, that is going to be increase in effective stress. So now let's classroom practice questions. 11 and 12. So this is a ground level, and there is a sand layer, and there is a clay layer. So you see, this is a water table, and moreover that there is a ground level. So here this soil is a sandy layer, and here it is going to be clayey layer, sandy layer and a clay layer. So now as it is a water table, then this is going to be saturated. The given saturated weight is going to be 18 kilonewton per meter cube, and here also gamma sat is going to be 20 kilonewton per meter cube. And apart from that, now a 4-meter fill is placed over an extensive area like this. See, whatever, this is nothing but the fill material, right? This is a fill of how many meters? 4 meters of unit weight, how much? 19 kilonewton per meter cube. So if that is the case, then on the top of it, there is a surcharge, because an external load is going to be applied over a large surface area. So now the surcharge is going to be gamma into 4, 19 force, which is going to be 76 kilopascals. You keep this aside. So this is surcharge intensity. So now what I am asking you, this is a question, still I did not discuss anything apart from the question. So now, yes, you see the clay layer thickness is going to be 5 meters, sand is 5 meters, and clay is going to be how many meters? 6 meters. So assume gamma W as a 10 only. And now what is the effective stress at the center of the clay layer? See, this is 5 meters, and here it is going to be 6 meters. So I am asking you, what is the effective stress at the center of the clay layer? At the center of the clay layer means this is going to be 3 meters, right? Here 5 meters, and here it is going to be 6 meters. So immediately after fill placed, immediately after placing of fill. So immediately after placing of fill, delta sigma dash is equals to 0, because immediately means time t is equals to 0. Initially, you know that entire pressure will be taken by water, no change in the effective stress. And after many years, which means time t is equals to infinity, then delta sigma dash is equals to q. So now yet center of clay layer, whatever the effective stress is nothing but effective stress due to self weight plus increase in the effective stress. at the center of the clay layer. I want to find out the effective stress, where this is due to self-weight, where this is due to external pressure or external load. So now you please find out the self-weight, sigma naught dash. So initial over burden pressure. Can you please tell me what is the initial overburden pressure over here? Please tell me. See, don't take the surcharge now. Don't take the surcharge now. What is initial overburden pressure? Which means only this sand and clay. That's it. Sand and clay. Mind it, don't take the fill. This is external load, right? So now I'm going to take the initial overburden pressure. This is due to only self-weight of the soil. So as there is a water table over here, then gamma dash of sand into 5. Gamma dash of the sand. See, at the center of the clay layer, right? I'm asking you. At the center of the clay layer, sigma naught dash is equals to gamma dash of sand into 5 plus gamma dash of clay into center, right? 3. So given gamma W as a 10 kilonewton per meter cube. So now I'll be writing directly, which is going to be 18 minus 10 into 5 plus 20 minus 10 into 3. So 18 minus 5, 8 5 is 40, 10 3. So which is going to be 70 kilopascals. So now the question number 11 says, immediately delta sigma dash is equals to 0. Then what is effective stress? 70 plus 0, which is going to be 70 kilo. And 70 plus what is Q? 76. 146 kilopascals. One 146 kilopascals. Mr. Babu Nayak. So questions are given chapter wise or zigzag manner. Whatever it is, like, can't you write that? So that's it about. See, the only change that you are going to observe over here is, sir, in CRPQ question 11, if it given overlies, then clay is above. No, see, overlined by, underlined by. If the sand is underlined by clay, then clay is above, sand is below. If the sand is overlies by clay, so overlies means the sand is above and clay is below. Sir, as in this problem, they mentioned to find out center. If they're not mentioned, see, while they're asking about the external, means these type of conditions, they will ask you at the center. In order to find out the stresses, definitely they have to ask you at the center. And if they ask at the settlement, then definitely you have to find out the center. And now, I want to include one more point. You see, you observe, addition of this question. Extra. Effective stress yet center of clay layer at a time where excess pressure dissipated by 60%. What is the meaning of this one? See, no dissipation of excess pressure. No dissipation of excess pressure. Yes or no? Because U bar is equals to Q. And here U bar is equals to 0. What is the meaning of U bar is equals to Q? 100% of excess pressure is there. What is the meaning of 0? Total excess pressure dissipated. Now I am asking you effective stress at a time at center of the clay layer at a time t where the excess pressure dissipated by 60%. If now you see, if excess pressure reduced by 60%, then reduced excess pressure will shift as increase in effective stress. I told you this point clearly. If you still have a doubt, you can look over here. So those people see. Now I'm explaining the point number 2. During consolidation, as pore water dissipates, then excess pressure decreases, and reduced excess pressure will shift as increase in the effective stress. So how much reduced excess pressure is there? Is nothing but 60%. Then what is the increase in the effective stress, which is going to be 60% of Q, which means 0.6 Q. I hope you understood the meaning behind here. So 0.6 Q. Then you tell me what is the total effective stress? Total effective stress means sigma naught dash due to self weight plus due to external load. See, you have to consider both. And what is 0.6 Q? 0.6 into what is Q? 76. Can you please tell me what is 76 over here? 0.6 into 76, which is going to be 45.6. So 70 plus 45.6. 115.6 kilopascals. I hope you understood this. So see, what I want to show you here is immediately what is the change in effective stress? 0. And as the time increases, pore water decreases. And how much reduction in the excess pressure will be increase in the effective stress? See, if 60% is going to be dissipate, then that 60% will be increase in the effective stress or not? Are sir, here you see, sir, after many years, 100% of the excess pressure dissipated, sir. Then the entire 100% will be developed as effective stress. What is meant by 100%? One, right? One of whom? Q. That's the reason why 100%, which means Q. 60% means 0.6 Q. 0%, 0. Yes, that's all. Increases means 1.6 comes now. Okay, fine. Those who understood, they can understood this. So increases by 1.6 by that is a will shift as will shift. You see this point. Then reduced excess pressure will shift as increasing effective stress. So what is increase? Initially, what is increase in effective stress? 0. Initial time t equals to 0, 0, right? It's not 1 initially. If you say it is 1, then increase means 1.6. But what is the initial effective stress? Increase 0. Now, let's see this one more question. Everybody see this question number 4. Question number 4, right? Please observe this question. After this one, I'll give a break. After this one, see a square footing. This is a previous gate question only. A square footing. Square footing is to be placed in a clay soil at a depth of 2 meters. So there is a square footing where the water table has risen up to the ground level as shown in the figure. You see, does this figure is exactly similar to whatever the model I have explained? Yes. Now you observe in this. Yeah. In this, I have given you, give me a minute once. Yeah. So in this, now what I'm saying you is this is a load and this is a square footing. Footing is a square footing. They mentioned in the question, footing is a square footing. Now load dispersion is 2 vertical to 1 horizontal. Gamma W they have given, gamma sat they have given. Whatever the load, net load Q is equals to 500 kilonewtons and CC is giving consolidation settlement, which means ultimate settlement. What is meant by consolidation settlement? Ultimate settlement. So SF means ultimate settlement only. Now, you see, lag. Okay, fine. I do one thing. I'll give you a break now. I'll give you a break. So you have a break. Meanwhile, you solve this question number 4. Meanwhile, you solve this question number 4 and let me know. So I want you to people to solve this question number 4. You please go through this question and let me know this question. Solve question number 4. Have a break. Now the time is 11:12. Class starts at 11:30. Yes. Yeah, I'm back. So the answer is 120 mm. That's in the classroom practice questions. I mean, I have provided the answers also. So you can please check those questions. And now, go back. So whatever the question I have given over here. So we need to find out the ultimate settlement. What is ultimate settlement? Cc by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. So you know that those who have done, that's fine. But those who have not, please look over this question. Classroom practice question, question number 4. So now, you know that Cc is given how much? 0.36. E naught is given 0.92. Then coming to the H. What is this H, sir? See, you know, H is a height of compressible clay layer, right? So when the H is the height of compressible clay layer, the load will travel or transfer through the base of the footing, which means beneath this footing only, whatever this is nothing but here, this is going to be the H value. So here, what is H now? Can you please tell me what is H? So this H is equals to 6 minus 2, which is going to be 4 meter. So stresses should calculate at center of compressible layer, which means now where we are going to find out the stress, we are not going to be find out the stress at a depth of 3 meters. We are going to find out the stress at a depth of this H by 2. So this is going to be H by 2. And now assume 2 vertical to 1 horizontal distribution. You know this is Z. What is Z? H by 2. And then this width, whatever the width we show over here, this width is going to be B plus Z. So now what is the sigma naught dash and delta sigma dash? So first of all, what is sigma naught dash? Water table is located at the ground level, right? Gamma dash of clay into 2 plus, what is H by 2? H is going to be 4 meters, right? This value is also going to be 2 meters. 2 plus 2, which is going to be gamma dash given as 19.3 minus 10 into 4. 9.3 into 4, which is going to be 37.2 kilopascals. And then delta sigma dash is equals to capital Q by B plus Z whole square. B plus Z whole square. So the Z is given as H by 2, which is going to be 4 by 2, which is 2 meters. So, and Q is given as 500 by 3.5 plus 2 whole square. So what is delta sigma dash? The delta sigma dash is 3.5 plus 2 whole square. So 500 by answer, which gives 16.53 kilopascals. So SF is equals to CC value 0.36 by 1 plus 0.92 into H 4 into log base 10. What is this value? 37.2 plus 16.53 by 37.2. So this SF value is equals to 37.2 by 37.2. So log of answer into 4 into 0.36 by 1.92, which gives 0.1197 mm. So this is in terms of meters, but generally we consider it as a mm, right? So what is the meaning of 0.1197 meters, which is going to be 11.97 centimeters or 119.74 mm. So if they ask rounded to 2 decimal, rounded to 0 decimals, then I can take it as a 120 mm. This is rounded to 0 decimals. If they ask rounded to 0 decimals, then you can take it as 120 mm. Else the answer is going to be 119.74 mm. Sir, is this a square footing? Yes, Mr. Rajkumar, they have given it is a square footing. Sir, can you tell me when to use gamma? Sir, given is gamma W, sir, in the examination. See, in the examination, if there is a fill in the blank numerical type, you please use gamma W10. And if it is a, sorry, if you please use gamma W 9.81 in the numerical type. Sir, it's not square footing. Arey Baba, given is a square footing. Baba. See the question. Given is square footing. Sir, why we take Z as 2 meters, sir? You please see, sir, what is mean by Z, sir? This value, sir. You please go through this one, sir. See, you see, what is this Z value? From this footing to this footing, what is this Z value? Z value is going to be H by 2. So that's the reason why I took Z as H by 2. It's need no need of the H by 2 every time, but from the given data, I have got it as a H by 2. So that's all about the question. And now let's see the next question. See the question number 2. See the question number 2, please, everybody. A normally consolidated layer settles by 1 centimeter when the pressure increases from 1 kg per centimeter square to 2 kg per centimeter square. When the pressure increases from 1 kg per centimeter square to 2 kg. So initially it's going to be 1 and it increases to 2, then the settlement is going to be 1 centimeter. Additional settlement for the same soil, for further increase of pressure from 2 kg per centimeter square to 4 kg per centimeter square. For 2 kg per centimeter square to 4 kg per centimeter square. So now, before going to this question, I will add one more additional data for the previous question. B, extra. If water table gets lowered by 2 meters permanently, increase in a change in ultimate settlement. Change in ultimate settlement. If water table gets lowered by 2 meters permanently, see, if you observe over here, for this data, if this is the condition, what is the initial? Initial is going to be 37.2. So now solution for this, listen to me carefully. Given initial is going to be how much we got? 37.2 kilopascal. 37.2 kilopascal. Okay. Now sigma 1 dash, let me take it as sigma 1 dash, which is going to be sigma naught dash plus delta sigma dash. This is due to external load. So 37.2 plus 16.53. 37.2 plus 16.53. What is this value, please? 53.73 kilopascals. Yes. So this is going to be 53.73 by 37.2. I hope you understood this. Now the question is, if the water table gets lowered by 2 meters permanently, change in the ultimate settlement. What is the change in the ultimate settlement? You know that from the point, if water table gets lowered, then effective stress will increase. Have you remembered this point? In chapter number 7, so I told you clearly, if the water table gets lowered, total stress decreases, pore water pressure decreases, and effective stress will increase. So if water table gets lowered, then effective stress will increase. So now, due to this water table effect, what is the change in effective pressure? The change in pore water pressure or change in total stress minus a change in pore water pressure. See, these are due to external load already there. So now you see this condition. Now you see this condition. What is a change in total stress? Observe in this. Okay, fine. In this, see, as unit weight above water table is not mentioned, assume gamma is equals to gamma sat. See, you look at this point. This is the assumption we have to make. See, I told you if water table gets lowered by 2 meters permanently, I am asking you the change in settlement. See, this is due to only self weight. And this is due to self weight plus external load. And now, if water table gets lowered, then effective stress will increase further. Yes or no? So now, as unit weight above water table is not mentioned, as I did not mention any water table, means any unit weight. So even though water table lowered over here, initially this is gamma sat. When water table gets lowered by 2 meters, still above is going to be gamma sat. I am assuming in that way. Then if the unit weight is going to be same, then the change in total stress is equals to 0. Then what is the change in effective stress? Minus change in pore water pressure minus gamma W into H. So as water table lowered by 2 meters, then the water level in the piezometer lowered by 2 meters. Like these questions, we have solved n number of questions. Minus 10 into minus 2, which is going to be 20 kilopascals. So now you see what is sigma 2 dash, sigma naught dash plus delta sigma dash due to external load plus delta sigma dash due to lowering of water table. So 37.2 plus 16.53 plus due to lowering of water table, how much? 20. What about this value? This value is going to be 73.73 kilopascals. 73.73 kilopascals. So now I will tell you the concept over here. I hope you understood what I have done here. If water table gets lowered, the effective stress will increase. So initially this is 53.73. Now you see sigma naught dash is equals to 37.2 kilopascals and sigma 1 dash is equals to how much? 53.73 kilopascals. See, when the stress is going to be increases from 37.2 to this total value is nothing but the 53.73, right? When the stress is going to be increased from 37.2 to 53.73, then what is the settlement over here? 120 mm. SF1 is 120 mm. Now, sigma 2 dash is going to be 73.73. See, am I asking you additional? Am I asking you change or am I asking you total settlement? I am asking you the change. Change means from here to here. From here to here, what would be the additional settlement? So let me take it as a SF2 over here. SF2 over here. So now from this point to this point, from 37.2 to 53.73, 120 mm. And now, first, let me find out. Now, from here to, let's take it as a SF2. So, now, SF is directly proportional to log base 10 sigma dash by sigma naught dash. So SF2 by SF1 is equals to log base 10 sigma 2 dash by sigma naught dash by log base 10 sigma 1 dash by sigma naught dash. Sir, why you have taken the directly proportional, sir? Sir, I am discussing about the same soil, sir. So CC is going to be constant, E is going to be constant, and H is also going to be constant. So this entire term is going to be constant. When this is going to be constant, then the remaining is going to be only this value. So now, if that's the case, you see, now substitute here, SF2 by, what is SF1 we got? 120 log base 10. What is the final? Due to lowering of water table and due to external load, the final is going to be 73.73. And what is initial? Initial means 37.2 by log base 10. So now 53.73. You know, for 120 mm, what is the final stress we got? 53.73 by 37.2. So can you please tell me what is this SF2 value? By log of 53.73 by 37.2 into 120. So after finding out, you're going to get 223.28 mm. See, what is the meaning of this one is, what is the meaning of this one is, Are Baba, everybody listen, now what I want to show. Look, due to this external load Q acting at the base, what is the settlement I got? 120 mm. Yes, I understood this one. Because due to that external load, the pressure, external pressure increased by 16.53. Now, apart from that, now not only the external load, but also there is a lowering of water table. If there is a lowering of water table, then due to external load, there must be some increase in the effective stress. Yes. Due to lowering of water table also, there is an increasing effective stress. Yes. So now by taking all the stresses into the consideration, all the stresses into the consideration. So due to external load, stress increases by 16.53. Due to lowering of water table, stress increases by 20. Then what is the final stress? 73.7. So for this pressure, what is the settlement? 120 mm. And now for the total, what is the total settlement? 223.28 mm. So now due to lowering of water table, change in settlement or additional settlement delta SF is equals to SF2 minus SF1. 223.28 minus 120 minus 120, which is going to be 103.28 mm. 103.28 mm. This topic is very confusing. There is nothing confusing over here. It's about you. You need to apply your mind over here. Just simply, I am looking over whole. What is the change in effective stress? That's it. The delta sigma dash is the only variable. Because did I change any sigma naught dash? You see, what is the sigma naught dash? Whatever the sigma naught dash I took earlier, that is a sigma naught dash. Yes, the every change is going to be seen every change is going to be seen only in this delta sigma dash. So the change is going to be happen. You know that when water table gets lowered, effective stress increases. When effective stress increases, settlement is going to be increases. So there was one previous IS question. The question was assertion, due to lowering of water table, settlement increases. Yes, due to lowering of water table, settlement increases. That was the assertion. And reason is, when the water table gets lowered, effective stress will increase. Yes, you know that when the water table gets lowered, effective stress will increase. Then when the effective stress increases, then the settlement is also going to be increases. I'll tell you other way. Logically, yes, your settlement is coming as 223.38. Yes, that is a 223.382. Okay, 220. No, not 38. It's going to be 28. You please check that. Mr. Kaushik, as effective stress increase, how can the settlement increase? See this equation you see. Now everybody please focus on this equation. Focus on this equation. What you know is, if water table gets lowered, then the effective stress will increase. Yes, everybody, yes. Okay. If effective stress increase, what is this? As the effective stress is going to be increases, what is meant by delta sigma dash? Effective stress. As the effective stress increases, then the settlement is also going to be increases. As the effective stress increases, then the settlement is also going to be increases. So that's the reason why I took as settlement increase, effective stress is also going to be increase. If you observe here, some of the people are asking, sir, why this 73.33 Aya? You see, if there is no water table, then this is the value. I hope you understood this value. Yes. What is this value? 37.2 plus 16.53. This value is nothing but 53.7. Okay. Now, my question is, you apply the load and you are lowering the water table. When you lower the water table, you know from chapter number 7, I explained you clearly, if water table falls, effective stress increases. Yes. So how much is going to be increases? How much is going to be increases? So now, as unit weight above water table is not mentioned, I am assuming gamma is going to be gamma sat. When I assume gamma is equals to gamma sat, then delta sigma is equals to 0. Then what is the change in effective stress? Minus change in the pore water pressure. So now, due to lowering of water table, effective stress increases by 20. So now what is the total effective stress at the center? At this center, what is the total effective stress? There is an initial overburden pressure. Yes, number one. And number two, due to lowering of water table, effective stress increases by delta sigma dash. Yes. Number three, due to external load, there is an increase in the effective stress. Yes. So now you add everything. Now, if this is the final stress, what would be the final settlement? 223.28. Then what is the increase in the settlement? 103.28. 103.28. Now, the logic is, let's say, here you see, change in settlement occurs when in other words, you see, in other words, I'm going to take it as in this way. The same one, sigma naught dash is 37.2 kilopascals. So now sigma 1 dash 53.73 kilopascals. So what is the settlement over here? 120 mm. So now let's take sigma 2 dash. After lowering of the water table, the stress is going to be increases by 73 means increases to 73.73. Sir, from the diagram, it should be B plus Z into L plus Z. Are Nana, this is square footing, Nana. This is square footing. This is square footing, right? As it is a square footing, that's the reason why I took, see, this is 3.5 plus 2 not into 2, that is square. The given question, the footing is square. They mentioned it clearly. Please look over that. Sir, why delta sigma is going to be 0? What is mean by delta sigma? Change in total stress or not? Okay, fine. So now I'll tell you, okay. After the lowering of water table, gamma minus gamma sat into how many meters you lowered? 2. So I assumed gamma is equals to gamma sat, right? Then what is the delta sigma? The delta sigma is equals to 0. Sir, is that increase in settlement is due to increase in void ratio, due to lowering of, see, Mr. Kaushik, the increase in settlement is not due to increase in the void ratio. When the water table gets lowered, see, due to lowering of water table also settlement will occur. That's what I want to say. Due to external load, settlement occurs. Not only that, when you lower down the water table, effective stress increases or not? Yes. During consolidation, you know, effective stress increase. So when effective stress increase, then definitely settlement occurs or not. So that's what I want to say here. Sir, what if water table rises, sir? Sir, the same thing, you please find it out, sir. Then you can find it out. My dear Nikhil, sir, on lowering water table, the initial effective stress changes. What is the meaning of initial? Please tell me. What is the meaning of initial? At first, right? Initial means whatever the initial conditions. And then when you lower the water table, effective stress is going to be increases. So initial plus whatever the change is nothing but final. So when you lower the water table, that is going to be final. And before lowering, there must be some initial or not. So due to lowering, the initial values are not going to be changed. Sir, I am always getting some error in calculation, which is very minute. I am afraid that it will affect my marks. Don't worry, Nana. See, if it is an MCQ, you can get directly the question. And if it is a range type questions, they will ask you, rounded to 2 decimals. So you can round it 2 decimals over there. And if they don't mention anything, they will give you the range. For example, I got 119.74. You might got 119.86. Then the range I will be given as a 119.50 to 120. So your value and my value will be in that range. So don't worry about that. Now, see, now I'll be explaining in a different way because I want to show you, look, I want to find out additional settlement. Yes or no? Are Baba, listen to me carefully. If the effective stress increases from 37.2 to 53.73, the settlement is going to be 120 mm. Yes or no? Yes, because I have proved this one. Because what is initial? 37.2, and what is the final over here? So here I will be writing the final. Sigma f dash means delta sigma dash. So what is the final? 53.7. So when effective stress increases from 37.2 to 53.73, the settlement is 120. Now, due to lowering of water table, the effective stress is going to be rises from 53.73 to 73.73. What is the additional settlement? What is the additional settlement? Let's take the SF2 as additional settlement. If I take SF2 as additional settlement, if I take additional settlement, SF2 as additional settlement, which means I'm not taking total. So I'm just checking whether I get the same value or not. Let me show you. So now with the same equation, now SF2 by 120 is equals to, but this time I take, I'm asking additional settlement, right? Additional means from 53 to 73, how much extra? Now, what is this final? 73.73 by initial 53.73. Keep that in your mind. This is always, this is initial and this is final. This is initial, this is final. Settlement directly proportional to final by initial, log of final by initial. So log base 10. Now for this 120 mm, who is initial? That's 7.2. Who is final? 53.73. So now 53.73 by 37.2. Can you please tell me what is SF2 here? Find out this value. 73.73 by 53.73. So log of answer by log of 53.73 by 37.2 into 120. So I hope everybody got this value as a 103.34 mm. I hope this value also would be the same way, like log of 73.73 by 37.2 by log of 53.73 by 37.2 into 120. Yes. So now I hope you got, see, almost all the value is going to be same or not. So now this SF2 is additional settlement directly. This is additional settlement. See, either you can find out the additional settlement directly or you find out the total settlement. Total settlement means from the initial to the final. From the initial to the final. This is earlier settlement and this is going to be final settlement. Then due to lowering of water table, what is additional settlement? This is the additional settlement. So I hope you understood this one. You please go through this one. Sorry. No, sir, is lowering of water table leads to loss of strength due to increase in settlement? No. Actually, in fact, the settlement, the disadvantage over here is a settlement and advantage is increase in the shear strength. You please go through yesterday's notes, then you will get that. Surrender class early as soon as possible, so we will prepare well. Arey, kya re bhai? So if I leave now, then you will prepare this 1 hour also. And one more thing, as most of the students are presenting, I don't know why the number of people are reducing divided. I hope, are you able to understand the classes or not? First thing is first, I hope you people are able to understand the classes. If not, please let me know. Are you able to understand my classes? No, sir. Okay. Okay, fine. From chapter number, some people from chapter number 11, you people are not understanding. Some persons say, see, you please go through the notes once. I'm not giving much points also. I'm just going through the basic things. Yeah. So some of the people will be saying, yes, okay, fine. See, this chapter like is very, very important chapter. You please go through the notes. I mean, if you after the class, if you go through the PDF, you will be getting to know the beauty of this chapter. And some of the people are thinking this is a boring chapter. No, it's not at all a boring chapter. Your imagination is boring, might be. So if you can imagine well, then it's a very, very, very important chapter and very interesting chapter. So the people who are saying no, you please go through the notes once again, and you please go through my video once again. And still, if you are not able to understand, then you come to me, you mail to me, and I can discuss with you personally also. Yeah, so some people who are having a problem with this class means with this chapter, you please go through the notes once again. Then you will be definitely able to understand all those things. Yeah, most of the some of the people might be habituated with the offline classes, so they might be having some boring over here. And you see, if it is an online offline class, I will be seeing your faces so that I can crack some jokes or I can say some stories also. But in the online sessions, it's like you can see me, but I cannot see you. So even if I want to say something else, I don't know how many of you people will try to get it. And some of the people might think that I might be wasting your time. So I don't want to waste your time. So mostly I'm focusing over the class only. Yeah. So after today, you can read this. Okay, fine. So now, some of the people sir, enough for today, enough for today, enough for today. Okay, fine. So now let's see the next question. Yes. So why I have explained this question is, you please observe. See, I made this continuity so that you can understand the level that an examiner can go through. I can give you in the same question, not only the load application, but also I can lower the water table. Then what happens to the unit weight? So now, if you understand this topic, let's go to the next question. Yes. Just now, a normally consolidated clay layer settles 1 centimeter when the pressure increases from 1 kg to 2 kg per centimeter square. 1 kg to 2 kg per centimeter square. Additional settlement for the same soil for increase of pressure from 2 kg per centimeter square to 4 kg per centimeter square. So now you see this question number 2. In question number 2, classroom practice question number 2. So given initial is going to be 1 kg per centimeter square. When the stress is going to be increases from 1 kg per centimeter square to 2 kg per centimeter square, the settlement they got is 1 centimeter. Now, if the stress increases from 2 kg to 4 kg per centimeter square, what is the additional settlement? What is the additional settlement? They are not asking you total settlement, they are asking you additional settlement. So for 1 to 2, 1 centimeter, from 2 to 4, 2 centimeters. Now, some of you people may ask you, Arey sir, SF is equals to MV into H into delta sigma dash, sir. And I can write SF is directly proportional to delta sigma dash, sir. So if this is the case, I know the delta sigma dash, sir, I can find it out. I'm telling you clearly, you cannot use this one until or unless mentioned. I told you clearly. In you please look over this point. Yes. For engineering calculations, to whom you are going to give preference first? For engineering calculations, we prefer CC equation out of all the coefficients. We prefer CC equation out of all the coefficients. So here, if they don't mention anything, you use CC. And if they do mention something, then only you go for the MV. So in the given question, they did not mention anything. So don't prefer MV because MV is not a constant. So in the question, if MV is going to be constant, then only you prefer this equation. I hope you understood the point. So now I am not going to use this one. So I am going to use the equation SF is equals to Cc by 1 plus E naught into H into log base 10 sigma dash by sigma naught dash. So if I write yes, then this is going to be sigma dash. If I write SF, then it is going to be sigma F dash. So now observe S2 by S1 is equals to log base 10 by, for S1, what is initial? 1. What is the final? 2. For S2, final 4 by initial 2. For S1, log base 10, final 2 and initial 1. I hope you understood this one. For the S1, this is initial, this is final. For S2, 2 is initial and 4 is going to be final. So log 2 by log 2, which is going to be 1. So which means S2 is equals to S1. Then what is S2 value? 1 centimeter. 1 centimeter. So this is the additional settlement. For understanding of this one, I made an additional in this problem. So once the examination is going to be done, you please go through this question. This is very, very good question. Okay, and one more thing, the people who are attending, see, some of the people might be thinking that sir, today examination. You see, I am telling you one more point. Please listen. The examination will be conducted at 6:30. Okay, and that paper will be like a test series only for you, and it will be there in your login. It will be there in the login for the next 1 month. For the next 1 month, it will be there. So whenever you want to attempt, you can attempt without seeing anything. See, you cannot get the answers directly. Once you attempt the exam, then only you can get the final answers. Okay. So what I mean, I have made a clear clarification from the people, means from the staff team. I got to, means they said that, see, the people, the students who attend in first hour of exam will be considered for ranking, and top 10 students names will be displayed tomorrow. Will be displayed tomorrow. Which means the students who attend in the first hour, so you can attend 6:30 p.m. to 7:30 p.m. in between this time. As some of the people are asking me, sir, we are having namaz, can we attend at 7 o'clock? Yes, you can attend at 7 o'clock. You can write the test tomorrow also. You can write that test day after tomorrow also, but the test will be available from 6:30 p.m. onwards. Okay. The test will be available from 6:30 p.m. onwards. You can write the test today or tomorrow or day after tomorrow after 10 days also. But those whoever are going to be given the test today in the first hour, 6:30 p.m. to 7:30 p.m., they will be considered for the ranking. So the people who are going to be right beyond that and tomorrow, they won't be considered for the ranking, but you can get down the solutions and you can get down the answers after you attempt the test only. Just like that test series, it will be in your login. You can attempt the test in the next 1 month. But if you attempt the test today, you will be knowing where you are throughout the India. So it's up to you. If you think you prepared well, you give a test today. And if you think you didn't prepare well, you require some time, you go for tomorrow. and then you can check the score that you are getting, but you don't get the all India rank over here. So that's what I'm saying here. Yes. So I hope everybody listened. So you can attempt the test tomorrow also. That test would be there in your login details. Until the point you are going to attempt the test, it won't display any rankings, or it won't display any solutions. So you attempt the test today or tomorrow or day after tomorrow, it's up to you. But the people who think that you have prepared for the 10 chapters, you give a test today, and the time starts at 6:30, and you can attempt the test in the first 1 hour of the test, 6:30 to 7:30. So whenever the time you start, from the time 75 minutes is going to be the time of the test series, time of the test. So you can attempt any time, but the duration of the test is going to be 75 minutes. Yes, virtual calculator will be available. Sir, will this chapter end today? No, it won't end today. It won't end today. This is not it's not a small chapter. It is a big chapter. So now, let's see the next questions. So the one question that I'm going to discuss here is, you observe here, please. Question number 13. Question number 13. A building was to be constructed on a clay stratum. A building was to be constructed on a clay stratum. Preliminary analysis indicated an ultimate settlement of 250 mm. See, a building was constructed. So this is a structure, and a building was constructed on the, means this is a building constructed on the soil mass. Preliminary analysis means without doing proper analysis, they have assumed the ultimate settlement as 250 mm. The average increase in the pressure in the clay stratum was 24. So the average increase means the increase in the at the mid height of the clay stratum, they have given as 24 kilopascals. So due to the building, the following variations occurred from the assumptions used in the preliminary analysis. Look, I have constructed one building, and due to that building, at the center of the clay, the average increase in stress delta sigma dash is 24 kilopascals. And the final settlement I have measured as, means preliminarily, I have said as 250 mm. Now, the following variations occurred from the assumptions used in the preliminary analysis. See, based upon the assumptions in the primary analysis, there are some errors. The errors are, whatever the borings that we have done, that borings indicate 20% more thickness, 20% more thickness for the clay stratum than originally assumed. Which means in the preliminary analysis, I took the thickness as H. But the original thickness is 20% more than the assumed. And second one is, during construction, means during the construction of the structure, the water table got lowered permanently by 1 meter. Just now I told you, if water table lowered, the ultimate settlement will increase or not. So the preliminary says it is 250 mm. But now the water table has been lowered by 1 meter permanently. Determine the ultimate settlement by taking gamma W as 9.81 and MV is constant. Now you see what I have given is the MV is going to be constant. So let's spot out this data. Question number 13. Question number 13. So according to this question, what is the data I am providing you here is given. First, in the preliminary data, I took the initial thickness as H, and the average increase in the stress is going to be 24 kilopascals. This is what given. And what is the ultimate settlement given? 250 mm in the case of the preliminary data. But after entire the primary or final data, the final data shows, give me a minute. So now, whatever the final data I have been provided you, so the given final data is, I assumed H, but the boring says, but the boring indicates 20% more thickness than the clay stratum. Given is 20% more thickness means, what is the meaning of 20% more? Which means 1.2 times of H. And due to, and one more thing, water table got lowered permanently by 1 meter. What is the meaning of this one, sir? So initially water table is going to be this level, and final water table is going to be this level. See, this is A and here it is going to be B. See, this is water table lowered by 1 meter. Now, did they mention any unit weights in the question? Have a look over here. In this question, have I mentioned any unit weight? Any unit weight of the soil mass? No. So now, in the previous question, I already gave you, in the previous question, I already mentioned, you observe, as unit weight above water table is not mentioned, I assume gamma is equals to gamma psi. As unit weight of soil not mentioned, then assume gamma is equals to gamma psi. Assume. So then delta sigma is equals to 0 and delta sigma dash is equals to minus delta u. Same thing. What I have explained over here, you see this portion, whatever I have explained over here, I am explaining the same way. Minus gamma w into delta HP minus 9.81 into minus 1, which is going to be 9.81. Then what is delta sigma 2 dash, sir? Sir, what is initial one, sir? 24. What is now 24 plus 9.81? 33.81 kilopascals. 33.81 kilopascals. See, I hope you understood what I have mentioned over here. Yes. So due to the lowering of water table, definitely the effective stress is going to be increases. How much it is going to be increases? How much is going to be increases? See, now it is going to be 33.81. So given MV is a constant, they mentioned this. How this condition is mentioned in this previous question? No. As I did not mention in the previous question, then I go for the CC. Now as MV is going to be constant, then I can use SF is equals to MV into H into delta sigma dash. So now MV is going to be constant. So from this, can I write SF2 by SF1 is equals to H2 by H1 into delta sigma 2 dash by delta sigma 1 dash. So SF2 by SF1 as 250 is equals to 1.2 H by H into delta sigma dash 33.81 by 24. So now what is SF2 after solving this one? 33.81 by 24 into 1.2 into 250. So the answer is going to be 422.63 rounded to 2 decimals. M. This is the final answer. So what happened over here is I assumed the original H, but compared to original, the original thickness is going to be, means I assumed this one H, the original thickness is 20% more than assumed. What I assumed is H, then it should be 1.2 H. So I hope you understood this question. With this question, I have concluded how to determine the ultimate settlement and what is the effect of water table, and you can see how to find out the stresses immediately and after many years and all those things. You please go through all these points once again. Mr. Kaushik sir, can we articulate like due to lowering of water table, the contact between particles increase? Yes, due to lowering of water table, contact between particles increase, thereby effective stress increase. Yes, and settlement increase due to increase in the void ratio. Arey Baba, what is mean by, see, you said everything correct, and how come the void ratio increases? When effective stress increases, void ratio decreases. That is the main point we're focusing on from the starting onwards. Yes. That's the main point we are focusing from the starting onwards. What is the meaning of this one? As effective stress increases, void ratio decrease. The void ratio will not increase. No, it's not at a water table. Yes. So now let's discuss the next things. I hope you got this point, and the next thing now. Soils based on stress history. What are the soils based on the stress history? So yes. So what about the soils based on the stress history? Now, I told you some of the soils like normally consolidated clay, which represents NCC. Second one, over consolidated clay, as OCC. Under consolidated clay, UCC. See, I was saying you that one of the soil is NCC, NCC, NCC. Now let me discuss about this NCC, OCC, and all those things. Suddenly the video and audio has gone. No, I am here only. Yes. Okay, now. So let's see what is mean by this normally consolidated clay and over consolidated clay and all of these things are. So see, what is the meaning of this stress history, sir? Whatever the discussion I have made so far over here is going to be effective stresses or not. Effective stress. See, if I say stress, then from now onwards, because you know that total stress is going to be constant as long as the external load is there. But effective stress slowly increases. And due to effective stress only settlement is going to be happen. Mind you. Due to effective stress only settlement is going to be happen. So I can write this point over here as one of the conclusion. Due to lowering of water table, effective stress increases, results in increase in settlement. Results in increase in settlement. So now you see normally consolidated clay, and when the stresses are going to be changed, the nature of the soil is also going to be changed. Now I'll ask you one question for you. Do you think whatever the structure, that is present, means the structure that you are going to be stand, or the structure where you are living, do you think that is the first structure that has been constructed on the soil mass? Do you think that is the first structure, or whatever the stress acting on the soil mass now, do you think this is the first stress acting on the soil mass? No. In its past, it may have experienced or may not have experienced. And if, see, for example, right now, I'm in an apartment. So before this apartment, a few years back, on the same soil mass, there may be an individual house. See, that individual house or villa load is very less compared to the apartment load. So the same soil 10 or 15 years back has been subjected to some pressure. And now, due to this apartment, it is subjected to some other pressure. Yes. So compared to the past, the present stress may be more or may be less. So this soil mass where I am living, this soil mass has experienced some stress in the past and in the present. Now comparing these past and present stresses, we are going to define the soils as normally consolidated clay, over consolidated clay, and under consolidated clay. So now, what is the meaning of normally consolidated clay at first? Normally consolidated clay means if a soil has subjected to stress or present stress more than the previously applied stresses. If a soil has subjected to present stress as more than previously applied stress, then you are going to say it as a soil is normally consolidated. Or if a soil is has subjected to maximum pressure yet present than past and got consolidated under present stress and got consolidated under present stress, then we are going to call it as a normally consolidated clay. So in simple words, if the present stress acting on the soil is more than the past stress, then the soil is going to be normally consolidated. For example, 10 or 15 years back, here where I am staying, there may be a residential building or an individual home. Now, after 15 years, they demolished the building and they constructed a big apartment. Now, due to big apartment, the present stress, due to individual structure, past stress. So now apartment pressure is more than the individual house or not. So present stress is more than the past stress and the soil is consolidated under the present stress. And the soil is consolidated under the present stress. Then we call it as a normally consolidated clay. So this is going to be the normally consolidated clay. In simple words, present stress is more than the previously applied pressures. So now the opposite of this one, second one, over consolidated clay represents with OCC. Over consolidated clay represents with OCC. So now in the case of the OCC, if a soil has ever been subjected to maximum stress in past, now you see in past, maximum stress in the past and got consolidated under past stress and got consolidated under past stress. So in simple words, I can write past stress is greater than present stress. So here present stress is more than the past stress. So if the soil has ever been subjected to maximum stress in the past and got consolidated under the past, then you are going to call it as a over consolidated soil. See, this over consolidated soil clay can also call as pre-consolidated clay. Pre-consolidated clay. So now, what are the causes of this over consolidation? What are the causes of? Say, tell one example of NCC. If that's what I said. Now, if a residential building is going to be replaced with an apartment, then it is going to be NCC. And most of the soils we are doing is NCC. For example, you have an empty plot, right? For example, you have an empty plot. Now you want to construct a structure. Before construction of a structure, the stress is 0. Now, when you construct your structure on the empty plot, the stress is going to be more. Present is more than the past or not. Now, causes of OCC. If a surcharge was applied earlier and got removed. You see, if a surcharge was applied earlier and got removed, which means if in the past there was some surcharge on the soil, which means the pressure is going to be more or not, then you remove the surcharge, then the stress is going to be less. So past due to surcharge, stress is more, and when you remove, stress is less. So past is more than the present, that caused the OCC. And if a soil is capillary saturated and got destroyed by rise of water table. I'm giving some examples. These are the examples over here. So see, you remember the point when there is a capillarity, capillary pressure increases the effective stress. I hope you know that point. If the soil is capillary saturated, effective stress is more. Yes or no? Yes. And now, and got destroyed by rise of water table. Are Baba, when the water table rises in the capillary zone, what happens? Effective stress. Due to rising of water table, effective stress decreases. So earlier, in the past, if the soil is capillary, effective stress is more. And if the water table rises, it causes the lowering of effective stress. So past, due to capillarity, effective stress is more. Present, due to rising of water table, effective stress is less. Stress in past is more than the stress in present. Then you can say it as a OCC. And third one, continuous erosion of overburden soil. See, you know, and etc. and etc. So, you know, see, these are some of the reasons I'm giving you, but you know that over a period of time, when the soil undergoes erosion, then the ground level is going to be gradually lowered or not. Means if the soil gets eroded, then the weight of the soil will be removed. That also causes OCC. So this is going to be the OCC, which means the present stress acted on the soil, the past stress acted on the soil will be more than the present stress. So now, note point. NCC and OCC are two different conditions of same soil, but not different soils. NCC and OCC are two different conditions of same soil, but not different soils. Mind it. Now, NCC is more compressible than OCC, and OCC is stronger and denser than NCC. See, this NCC and OCC are just like a dense sand and loose sand. Dense sand has more strength, loose sand has lesser strength. Dense sand undergoes less compression, loose sand undergoes more compression. So, what is the meaning of OCC? The soil has been already consolidated under the present stress. You see, the soil has been subjected to the maximum stress in the past and got consolidated under the past stress. So, got consolidated under the past stress. Now, last one. Under consolidated clay, UCC. Under consolidated clay, so which is going to be UCC. This UCC means soil has subjected to stress present stress more than past stress, but maximum stress are the soil that has been subjected to present stress more than the past stress. So compared to the past stress, the present stress is more, but maximum stress has not reached yet or during the consolidation. See, I said that got consolidated, which means consolidation completed. And here also consolidated under the past stress. But in the case of the UCC, the soil is having a present stress more than the past stress, but maximum stress has not reached it during consolidation. So example over here is during the stage of construction, soil will be under consolidation, which means consolidation not completed yet, or construction not completed yet. See, these are the three conditions. For example, I'm just showing you. See, if this was a ground level, in its past, if there is a small house like this in the past, and now there is a big framed structure like this. Now, this is a present. Yes. So this is a clay and this is also going to be a clay. But what is this past? Past stress is going to be less. Past is less. Present is going to be more. Past is less. present is going to be more, and the soil consolidated under present stress, then this soil will be known as NCC. So when do we say NCC? If the present stress acting on the soil is more than the past stress and got consolidated under the present stress, we call it as NCC. Now you replace. You say this is the past and this is going to be the present. You say this is the past and this is going to be the present. So past is going to be more and present is going to be less. So which means the soil got already consolidated under past or not? When the soil got already consolidated under past, then the present stress is going to be less than the past stress. So now the soil is going to be OCC. Now the soil is going to be OCC. If the present stress is less than the past, or if the past is more than the present, then we call it as a OCC. And now this is past. Now the structure is under construction. When the structure is under construction, this is under construction, then the soil will be under UCC. See, during the construction of a structure, and the present is going to be more than the past. The present is more than the past. This is the present more than the past, but the construction has not completed yet, which means the soil has not consolidated full. Then we call it as UCC. I hope you understood the differences between the UCC, NCC and OCC. And in order to differentiate all these things, we have one ratio known as over consolidation ratio, represented with OCR. This is to differentiate OCC and NCC. This is to differentiate OCC and NCC. Now, what is OCR, sir? OCR is equals to pre-consolidated stress by present stress. So I can write this one as a pre-consolidated sigma C dash by sigma naught dash. Sir, what is mean by pre-consolidated stress, sir? Pre-consolidated stress means the stress at which soil got consolidated previously. The stress at which soil got consolidated previously. This is known as a pre-consolidation stress. What is meant by pre-consolidation stress, sir? The stress at which soil got consolidated previously. Now you see, this is a definition of the OCR. So what is OCR? OCR means pre-consolidation stress by present stress. So let's see. Okay. For NCC, see what is meant by NCC, please tell me. What is meant by NCC? NCC is if a soil has subjected to maximum pressure and got consolidated under present stress. In the case of NCC, the pre-consolidated pressure. What is the meaning of pre-consolidated stress or pressure? The stress at which soil got consolidated previously. So now, when do you say NCC? If the soil got consolidated under present stress, then only we say it as NCC. which means in the case of NCC, pre-consolidated stress is equals to present stress, which means OCR is equals to 1. In the case of NCC, Now, in the case of OCC, pre-consolidated is equals to past stress. Sir, why you have taken this one as why you have taken the OCR as 1, sir, over here? You please tell me. In the case of the NCC, the definition of NCC is if the soil has subjected to maximum in the present and got consolidated under present, which means the soil got consolidated by what stress? Present stress. So then what is the pre-consolidated stress? Present stress. Now, if I keep this pre-consolidated stress as a present stress, pre-consolidated stress as a present stress, pre-consolidated and present both are same, then OCR is going to be 1. And now, in the case of OCC, soil got consolidated under past stress. Soil got consolidated under past stress, which means the pre-consolidated is nothing but the past stress. Now, you insert in the OCR. So, the OCR is equals to past by present. Then, you know, always in the case of the OCC, when the past stress is going to be more than the present stress, in the case of OCC, OCR will be always greater than 1. OCR will be always greater than 1. Why? Because in OCR, what is the pre-consolidation past? Past by present, right? In OCC, past is more than the present. Past means numerator, present means denominator. In OCC, past is more, present is less, numerator more, denominator less. And sir, what about for the UCC, sir? In the case of UCC, see, OCR is equals to 1. OCR is equals to 1. Yes. OCR is greater than 1. Then what is remaining? OCR 1 हो गया. OCR greater than 1 हो गया. Then what is remaining? OCR is less than 1. OCR is less than 1. Here, OCR is less than 1. So, R, in the case of the UCC, pre-consolidated is equals to past stress. Because you see, soil has subjected to present stress more than the past stress, but maximum stress has not reached at or during the consolidation, or soil consolidated previously with past stress. See, due to present stress, soil will be under consolidation, and due to past stress, soil got already consolidated or not. So, what is the meaning of pre-consolidated stress? The stress at which soil got consolidated previously. In the case of UCC, under present stress, soil will be under consolidation, but due to past stress, some part of consolidation will have happened or not. So now, in the case of the UCC, OCR is less than 1. OCR is less than 1. So now, these are the OCR values for NCC, OCC and UCC. So when OCR is going to be 1, because when the normally consolidated clay, when do you say normally consolidated clay? soil consolidated under present stress. So pre-consolidated is present, present by present, OCR is equals to 1. And when do you say OCC? Soil consolidated under past stress, which means past by present. And you know, in OCC, past is more, present is less. So answer is going to be more than 1. And in the case of the UCC, present is more, past is less. So pre-consolidated is past, past by present, less by more, OCR less than 1. So these are the over consolidation ratios. So these are the definitions of the OCC, NCC and UCC. And I have given you the over consolidation ratios. So you please go through this. Today, so it's up to you. If you want to go for the examination, you can, and it's up to you, I'm telling you. So it's up to you. So if you want to go for that, you can go for the examination, or please go through this once again. So now with this, I am concluding the session. And today there is no doubt clearing session because we have just started this topic, right? You please go through the notes, and today you prepare for the examination, and you please go through the consolidation chapter. So that's see, and I'm telling you again, if you feel you prepared, then you give a test. Else, if you want to, sir, I will give the test at the end of the syllabus. You can give the test also. It's up to you. I'm not going to bother you. But the people who are going to attend the test in the first 1 hour, means 6:30 p.m. to 7:30 p.m. those who are going to log in and those who are going to have a test, they will be considered for the ranking. And if you write the test tomorrow, you will not be considered for the ranking. So it's up to you. Means if it's not important of rank for you, that's fine. And if you want to know your rank and where you are standing also, you can write this. So with this, I'm concluding today's session. So I'm not going to take any doubt clearing section because I have one more session in the afternoon. So we'll be taking the doubt clearing session tomorrow. Okay, fine. Up to that point. So let's see any other comment section. So let's see. Sir, when pore water started to dissipate, volume decreases. If so, there won't be any settlement. Or, sir, when pore water starts to dissipate, volume decreases. You said very good. If so, there won't be any settlement. Yes, there is a settlement, right? How come the pore water is dissipate? By means of the external load only, right? Or only after stress has been taken by the soil settlement occurs. See, when the pore water dissipate, water says to solid, "Arey solid, I am going out. You please take the load." Then the solid will take the load. Then particles undergo compression. Then the volume decreases. Sir, if removed surcharge is less than the present stress, and also it is going to be OCC. Arey Baba, surcharge means external load. How come the pressure will be less when you means if the surcharge pressure is going to be less? No, it's not going to be possible. Sir, how do we know whether the soil has reached the maximum stress or not, sir? Because once the structure is going to be completed, if you complete the structure, then that is the maximum stress, right? Are we considering only clays here? Yes. Sir, is the clay under Taj Mahal is UCC? Have you demolished the Taj Mahal? No, right? Taj Mahal is there or not? Before Taj Mahal, there is no load. So that soil is still under NCC only. Sir, how will we determine soil in NCC, UCC, OCC practically? Practically, you conclude means you know previous stress and present stress, then you can conclude by means of the OCR. Sir, in UCC, why you take past stress as a pre-consolidated? Arey Baba, what is mean by UCC? Soil is undergoing consolidation, then which means it got consolidated due to past stress or present stress? Past stress only. For example, let's say, I mean, so that load is less, and due to that load, soil would have been undergone some consolidation. Soil would have undergone some consolidation. Now you remove the structure, and you are constructing the structure. During the structure, soil will be consolidated or under consolidation. Under consolidation, but the same soil has consolidated previously with what stress? Past stress now. Yes or no? So that's the reason why I took in the case of UCC, pre-consolidated is a past stress. Mr. Sir, I have exam today, final. Sorry, sir, I would not be able to attempt this exam, but I will try tomorrow. Yes, fine, it's up to you. Sir, once we attempt the exam, is it available again? No. Once you attempt the examination, it won't be available again. Means the paper would be there, and the result would be there, and answers would be there. It will be there, but you cannot attempt the exam as a fresh exam again. So day by day, you are reducing doubt clearing sessions. No, I am not reducing. I am giving time for you. I'm giving time for you to study more. When you study more, you will get more doubts. I can clear you all the doubts at the once. Arey sir, please explain overline, underline, overline, etc. Please, sir, it's so much of confusing. I think you messaged this one from the past 1 hour. I have seen those. I have explained all those things. Please go through chapter number 7 once. Effective stress, there I explained. You please go through that once again. Then you mail me. Sir, what is the minimum rank for general to get IIT or NIT? My dear Anonymous, you are asking me this question from a long period of time. See, the people who wants to live, they can live. And the general, if you want to get IIT in the case of the general, and with any type of specialization, if you want, you have to get a rank of less than 1000. If you want to join IIT with a general category, and if you want to take any branch, means any branch, environmental also, you can get less than 100, less than 1000. And if you want to get geotech, it's going to be less than 700 to 750. If you want to get structures, you have to get less than 200 to 300. Transportation, 250 to 500. So if you get less than 1000 gate rank, then you can get IIT. For NIT, you can go up to 2500 also. So daily at the time 6:30 only the test should be written. No, the test will be started 6:30 today, and you can write any time, tomorrow morning or anywhere. During settlement, is there any change in volume of soil solid? No, volume of solids never change. Is there any courier delivery for our books, as you said earlier? Yes, it will be there, but I don't know if the interstate delivery has not opened yet. So from state to state, the deliveries has not opened yet. The ACE staff team would be prefer the students only. They try to get maximum amount of information, maximum number of resources for the students first. You don't need to worry about that. As soon as all the courier services are going to be started, they are going to be definitely send you by means of courier based. So don't worry about that. Okay, fine. I'm going to close this. UCC, tell me once again. I have said Sunny, Mr. Sunny. I have said you. You please go go through the notes once again, and then sir, I Hyderabad experience for 1 minute. No, it's not going to be 1 minute. That will be taken hours. So I'll be explaining you some other day. So please answer my doubt. There are a lot of Mr. Anonymous attendees. Say I'm giving you personally. Please, if you are enrolling, you please make sure your name, because a lot of people are there. This is related to drainage condition. Yes, drainage. What is the meaning of drainage? Expulsion of water. That's it. That's not a some foreign or French term. That's drainage condition means if there is a possibility of water to go out, that is known as drainage. And if the water cannot go out, that's not drainage. So that's it. So for today, I will be logging out, and if you still have a I'll take this session, non-technical session of 1 day, but up to that, please hope I'll be taking the sessions further. Still a lot of time we have to spend everything. But now I have to leave. So I'll be leaving, I have saved all those details, and I'm going to send this PDF within 10 minutes. So please look over the PDF once again. Yes. Okay, bye for today.